We're going to focus on simplification now by using the trigonometric identities. So I'm taking these questions from the Via Africa textbook, chapter 6, exercise 2, number 2. We're going to do a few of them, but now we're just going to focus on number 2. Okay, so remember, what patterns do you know already from general algebra and exponents and things like that? And you're going to apply all of that to solve this. So first of all, let's have a look at what we have here. We've got a square root and two brackets underneath the square root, 1 minus sine x in a bracket times 1 plus sine x. Now, it's clear that we've got difference between two squares there. So very first step is we're going to multiply the two brackets and it will become 1 minus sine square x. So if you've done your memorization already regarding your identities and you are confident of that, you will clearly see that this is an identity. And if we simplify by using the identity, this becomes cos square x with a square root over it. And now we are applying the fact that a square root is the opposite of a square, or a square root means to the power of a half. So these two do cancel each other out. So your simplified answer is cos x. And you've got that one. The next question we're going to do out of the same exercise is number 4. So you've got cos x times, and inside a bracket you've got two terms, so it's cos x plus tan x times sine x. Okay, so the square identity can't be used here, not yet, or maybe not currently. But what we do see over here is we've got tan x. So currently we've got cos x, tan x, and a sine x in this equation, and you want to simplify it as far as possible. So that if you can change the tan x by using the quotient identity, this fundamental identity, into a sine x over cos x, we will have an opportunity to simplify this a little bit further. Okay, so let's do it. Cos x bracket cos x plus sine x over cos x times sine x. So this is our first step. Now you will recall that I always say that the moment you have a fraction inside a bracket with more than one terms, it makes life a little bit more difficult. So always try, if it works for you, if it suits your needs in this case, try to work towards a one fraction inside the bracket. And we can do that by getting a common denominator. So if we multiply with cos x divided by cos x in this term, in other words, you multiply by 1, we can get to a common denominator. Now let's look at this part. It's sine x times sine x, which makes it sine squared x, and our denominator now is cos x. And yes, then you start rejoicing because you can see that cos x and cos x cancel out. And inside the bracket, you only have cos squared x plus sine squared x left. And if you remember your identities, you know that that is the square identity. So the answer will just be equal to 1. So the next number is number 6. 2 sine x times cos x minus bracket sine x plus cos x close bracket square. do not fall into the trap of just saying, the square applies to both. I'm just going to put a square there. As you clearly know, it's not allowed. But first step is to multiply the bracket. So we are going to do that, but we're going to do it in the right way. So sine x times sine x becomes sine squared x. And sine x times cos x becomes a sine cos x. And cos x times sine x becomes a sine cos x. So this gives us a middle term of 2 sine x cos x. And then plus cos squared x, which becomes cos squared x. All of that in the bracket. So I'm just going to write it here. I ran out of space. So now it's 2 sine x cos x, and the negative will be multiplied into the bracket now, so it will be minus sine squared x minus 2 sine x cos x minus cos squared x. Okay, so 2 sine x cos x minus 2 sine x cos x, that becomes 0. So we are left with minus sine squared x minus cos squared x. Now it almost looks like the square identity, but it doesn't quite yet. In order for it to look like it, we can factorize by taking out a negative 1. And then you'll see inside the bracket you've got an identity. So negative 1 times 1, it's just equal to negative 1. The next number is number 8 from the same exercise, exercise 2. Okay, so again I have a scenario where we've got sine A, cos A, and tan A. Now we don't want 3 different expressions to work with, we want 2. So the very first thing we're going to do is we're going to apply the quotient identity. So this will become sine squared A plus cos cubed A times sine A, and as the denominator sine A times cos A. Let's just pause here, and I want you to understand this. Sine A divided by cos A is equal to tan A. We've applied the identity there. And there's no problem with writing it like this. So this is where it comes from. Now let's see, is there anything that can cancel out? Yes. Sine A cancels out. This cos A cancels out with one of those. So we will be left with sine squared A plus cos squared A. And that is indeed an identity which is equal to 1. Okay, let's look at number 10, exercise 2. And then you have this complex expression. Okay, so then you look at this 1 minus sine x as a denominator. And I want you to see that over here we've got 1 plus sine x. And this should ring a bell that you've got the possibility of the difference between two squares. But it's not just straightforward. We first have to get to a common denominator. There's many different strategies for this one, but I'm going to focus on the simplest one, the one that's the easiest to work with. So we will have 1 plus sine x multiplied by 1 minus sine x minus cos x times cos x, and we'll have a common denominator as cos x times 1 minus sine x. And it's always advisable to leave it in brackets as is. Don't multiply and make it more confusing. We're first going to simplify the numerator. Okay, so with the numerator we've got difference between two squares, so this becomes 1 minus sine squared x minus cos squared x. And as stated, we're going to leave the denominator as is for now. Then at the top, we don't have any identity we can clearly apply yet, but if we factorize by taking out the negative 1, this becomes sine squared x plus cos squared x, which is the square identity. So here we have an identity which is equal to 1. So you have 1 minus 1. Over the denominator, which really doesn't matter in this case because 1 minus 1 is 0. And that's the end of this exercise.